Hello everyone, thank you for joining us today for another webinar in our Market Access and International Approvals webinar series. My name is Crystal and I'm part of the Certification and Approvals technical staff here at Vista Compliance Laboratories. Today I'll be presenting to you the certification and approval regulations as well as the technical requirements for electrical equipment, electronics, and wireless products and device approval in Japan. Vista Laboratories is a Japanese Ministry of Internal Affairs and Communications, MIC, appointed registered certification body, RCB, and we offer certifications for radio devices allowing the use of the Giteki or Telec mark on your products. MIC certification is required for certain categories of radio devices prior to placing them into the Japanese marketplace. Your equipment needs to be assessed to applicable Japanese radio ordinance law, and then the results test reports are submitted, along with other documentation such as schematics, diagrams, bills of materials, and user materials to the RCB for evaluation. A successful evaluation of the submitted documents will lead to RCB issuing an MIC ID, which is required for placement on the Japanese market. Vista Laboratories is an EMC RF compliance test lab and product certification body and experts in global regulatory approvals of RF devices. So today, we will primarily be going over the requirements of radio frequency approvals in Japan. In this webinar, we will provide an overview of the major topics necessary to understand to get your device on the right track for authorization and distribution in Japan. If you have any questions on the topics presented today, or any other immediate questions regarding compliance testing and product certification, you can reach us at info@vista-compliance.com. Let's begin the presentation. So starting with a brief overview, what is MIC? The Ministry of Internal Affairs and Communications is the governmental authority which oversees market authorization for radio products granted based on the Japanese radio law. The radio law covers all products which utilize the radio spectrum and operate under 3 terahertz. There are multiple MIC scopes of application, including Certificate of Construction, Design, or Type, Technical Regulations Conformity Certification, and Declaration of Conformity, DOC. We will go into these in further detail in a later slide. MIC certification is required for products to be sold in the Japanese market. As part of the marketing authorization for Japan, manufacturers must also comply with the MIC requirements for electromagnetic compatibility, EMC, and electrical safety, while VCCI certification certifies that the device conforms to EMC requirements. PSE approval in Japan stands for compliance with the electrical safety requirements of the product safety, electrical appliance, and material safety laws. The Ministry of Internal Affairs and Communications has jurisdiction over many government agencies involved in the framework of the nation. For example, administrative, public services, finance, electoral systems, firefighting and disaster prevention, information and communications, and the postal services. But for our purposes, we are mainly interested in the communications part, specifically the Telecommunication Bureau, which covers the telecom and wireless technologies. Going back to the conformity assessment methods, the first is Technical Regulations Conformity Certification. This is where testing and certification will be conducted for each radio equipment. Next is Certification of Construction Type. This is where testing and certification is conducted on one sample unit for each type of radio equipment for approval of the construction design. Lastly, we have Self-Confirmation of Technical Regulation Conformity, where it's an SDOC or self-declaration, so you can simply perform testing without certification to confirm the equipment meets the TR. These are all parts of RF approval and not to be confused with VCCI. MIC has three main approval procedures in their conformity assessment system. The three ways to obtain approval are Certificate of Construction Design or Type, Technical Regulations Conformity Certification, and Self-Confirmation of Technical Regulations Conformity. In the case of Certificate of Construction Design or Type, the product, including construction and design, is certified on the basis of representative samples. MIC approval is granted if the product complies with the technical standards specified in paragraph 24 of Article 38 of the Radio Law. This approval process is particularly suitable for manufacturers of radio products that are produced in large quantities. In the case of Technical Regulations Conformity Certification, each individual equipment is tested for conformity, so testing and certification are carried out for each product. This process is primarily designed for equipment that is only produced in small batches, typically less than 100 units. Lastly, under Self-Confirmation of Technical Regulations Conformity or Declaration of Conformity, DOC, if the manufacturer is the owner of suitable measuring equipment, the test reports drawn up there can be used for a declaration of conformity. In this case, however, a local Japanese representative must apply for approval from the MIC. The first process is determining which conformity assessment procedure from the MIC conformity certification system to use. This could be Certification of Construction Type, Technical Regulation Conformity Certification, or Self-Confirmation of Technical Regulations Conformity. The next step is radio equipment testing. The requirements for this are dependent on the function of the device and what pertains to it based on the radio law. Testing must be performed by an authorized lab. After testing, the application and all supporting documents are submitted to the Certification for Technical Review, which is paperwork only. This process is how the MIC ensures that RF and telecom devices used in Japan operate effectively without causing harmful interference and otherwise comply with regulations. If all the documents are in order, the next step is for the CB to issue the certification and report this information to MIC, which will list the equipment on the MIC website. Finally, the product may be labeled and placed on the market. Here are the MIC regulated products. There are two main categories: specified radio equipment, where certification is mandatory, and special specified radio equipment, where certification is optional. Under specified radio equipment, there are unlicensed stations consisting of 20 classes such as wireless LAN, Bluetooth, cordless telephone, low power security system, UWB radar, and short-range devices. Licensed stations consisting of 38 classes such as CDMA, WCDMA, LTE, cellular devices, cellular phones, mobile earth stations, and land mobile stations. Other licensed stations consist of 101 classes such as base stations and wireless access systems. For special radio equipment, there's 15 classes of specified radio equipment designated as special equipment. They are special because these equipment rarely cause interference or other disturbances that would severely jam the operation of other radio stations. Special specified wireless equipment is the main class of equipment accessed for self-confirmation in the Technical Standard Conformity Self-Confirmation System. A manufacturer or an importer conducts verification and then the confirmation itself only when it is deemed that the construction type of the special specified radio equipment conforms to the technical regulations and that any and all specified radio equipment based on said construction design is ensured to conform to said construction design. MIC regulates all radio approvals in Japan. Here are some of the latest radio frequency regulations under the radio law in Japan. The different sections pertain to different frequency ranges or operations. Low power radio equipment requirements are found in Article 2, Paragraph 1, Item 8. 2.6 GHz band low power data communication devices requirements are found in Article 2, Paragraph 1, Item 19 through 19.2. 5 GHz band low-power data communication devices are found in Article 2, Paragraph 1, Item 19.3. Flight cellular phones requirements are found in Article 2, Paragraph 1, Item 11 through 19. And ultra-wide band UWB requirements are found in Article 2, Paragraph 1, Item 47. Here are the certification requirements. Testing can be tested locally or in-country. 1 to 2 samples. Lead time depends on complexity of the product. Documentation can include block diagrams, schematics, antenna specification sheets for RF approval, data rate. It contains each modification method and all data rates that product has. Test report, external photos, drawings, pictures of products, 6 dimensions, with notes on size, the length, the height, and the width. Pictures of each PCB, both sides. If PCB is shielded, both of shielded and unshielded. PCB layout, user manual, draft version, series product manual can be accepted. ISO 9001 certificate of application and assembly factories. The lead time can be as fast as 1 to 2 weeks or up to 4 to 6 weeks. For family model grouping is allowed. The model in the family grouping must be based on the same design. All product variants must all be based on the same design and may differ only in options and versions. Modular approvals, meaning certification of radio modules, are permitted. Host equipment, which contains one or more certified radio modules, can be labeled with the certification numbers of the certified radio modules. A label can be placed on the host device which indicates the presence of one or more certified radio modules in the host device and include the certification numbers of the certified radio modules. For permissive changes, meaning that the product's hardware and/or software are modified in a way that affects or may affect conformity with the technical requirements, the product must be subjected to additional testing. The additional test reports and all other supporting documentation are submitted with a modification application. It is possible for certified equipment, after going through a permissive change, to be allowed to continue to use the same certification number. In any case, each permissive change needs to be submitted to the certification body for review. If it is possible to keep using the same certification number, the certification body will then issue a new certificate for the same certification number, but with a revised date of issue. Please note that the certification number contains the identification number of the certification body which certified the device in question. Because of this, it is not possible to use just any certification body for Japan in case permissive changes need to be reviewed. Permissive changes must always be filed at the certification body which issued the original certificate. It is highly recommended to ask the certification body for their opinion on a case-to-case basis in case of intended permissive changes. The certification body can then provide the recommendation of how to test, where required, how to submit the permissive changes applications, and if the same certification number could still be used. Now let's take a look at labeling. Labels must be affixed in a prominent location that is easily visible to the user. For batch certification, the RCB must apply the labels in a prominent location after issuing certification. For type certification, the applicant generally handles printing and affixing the certification mark. In this case, the applicant should submit certification mark specification when applying for certification. Certification mark specifications will include label and mark dimensions, method of affixing, and the label's location. For products which contain more than one type of radio device, it is possible to obtain a single consolidated type certification number to avoid placing multiple approval numbers on the label. Both batch certification and type certification share the same certification mark with a symbol R in a black box and the certification number. The size of the mark must be 3 mm or more in diameter, as well as made of durable materials that cannot be easily damaged. The color of the mark may be chosen by the applicant so it doesn't clash with the branding of the product, but it must remain easily identifiable. The first three digits of the certification number indicate the Registered Certification Body (RCB) number. Ours is 216. The remaining digits are determined by the certification body as identification numbers for the equipment. E-labeling is allowed as an alternative to the physical marking of a conformity mark. It's a way to place a mark by electronic and magnetic means to the specified radio equipment based on the certified construction type, allowing it to immediately display the mark on the display or screen of the specified radio equipment. If the mark is attached to the specified radio equipment via an e-label, the process of displaying the mark by the specific operations or procedures are to be in clarifying attachment documents such as the user manual. The requirements for physical markings are also applied to e-labeling. E-labeling is a great option for smaller electronics or for software that is constantly updating. A certificate example is shown here. Certification information are publicly available and searchable on the MIC online database. Certificates do not expire and renewals are not required, although new certifications are required for products that have been changed. The certificate shows information such as the product specifications, certificate number, the certificate holder's name, address, contact information, and certification date. It also includes the technical specifications that have been approved for the product. MIC carries out market surveillance every year, so in terms of surveillance actions the MIC will take to ensure product compliance, MIC will purchase merchandise from the market and examine it for conformity with the technical regulations and contact the supplier to correct any non-compliant issues found. They will investigate further what happened. When equipment which violates the technical regulations is detected, MIC orders the supplier to correct it. After an investigation, MIC will publish notices in cases where non-compliance has been found. Common examples of non-compliances are undocumented changes in certified equipment, wrong test methods applied, unauthorized test reports were used to obtain a certification number, model names of certified equipment was changed, and this change in model name was not presented to the certification body. Now let's talk about some common violations of the law and their penalties. The first one is refusal to submit radio equipment to or provide reports to the MIC. Fines can be up to 300,000 yen. The second is the unauthorized use of the Geteki mark. This can cause you to be in prison for up to a year and fines over 100 million yen. Then there is non-conformance or interference, which is also 1 year imprisonment and fines up to 100 million yen. And the last is unauthorized changes to equipment, which can lead to fines up to 500,000 yen. When equipment which violates the technical regulations is detected, MIC orders the supplier to correct it after an investigation. MIC will publish notices in cases where noncompliance has been found. So we have taken a look at MIC and the radio law. Here is a look at the EMC and safety regulatory agencies VCCI and PSE. VCCI is the Voluntary Control Council for Interference, and PSE is a marking showing product safety. As part of the product authorization in Japan, manufacturers must also comply with the MIC requirements for electromagnetic compatibility, EMC, and electrical safety, while VCCI certification certifies that the device conforms to the EMC requirements. PSE approval in Japan stands for compliance with the electrical safety requirements of the Product Safety, Electrical Appliance, and Material Safety Law. The Voluntary Control Council for Interference, VCCI, is an organization set out to ensure electromagnetic interference emitted from information technology equipment distributed in Japan is controlled. Multimedia equipment, information technology equipment, audio equipment, video equipment, broadcast receiver equipment, entertainment lighting control equipment, or combinations of these are all within the scope of VCCI. Device functions may range from display, recording, processing, controlling, reproducing, transmitting, or receiving single, medium, or multimedia content or information. The content may be data, audio, or video, either individually or in combination. Generally speaking, any equipment primarily used in a residential environment is classified as Class B equipment and must meet the more stringent Class B limits. All other equipment must comply with Class A limits. Here are some of the EMC regulations under VCCI. These are based on international standards CISFR 32. What is the purpose of PSE? The purpose of PSE is to prevent hazards and disturbances caused by electrical appliances and materials. The manufacture, import, and sale of products are regulated under the DINAN Product Safety Law. Some products covered by PSE include AC/DC power supply units, extension power supply cords, TV receivers, electrical appliances, and LED lamps. Items that are not covered by PSE will include cell phones, desktop computers, built-in power supplies, and many more. Now, let's go over regulatory bodies one more time. MIC regulates all radio approvals in Japan. VCCI issues EMC approvals in Japan. PSE is electrical safety. Here are some safety regulations. For electric wires, see Appendix Table 1. For fuses, Appendix Table 3. For AC motors, Appendix Table 7. For electric appliances, Appendix Table 8. For batteries, Appendix Table 9. Now let's talk about importation. All products being imported into Japan need to be certified in order to be sold in Japan. Importation is not permitted if the device does not have the proper certifications. The certification is intended to guarantee an avoidance of interference between equipment and to protect consumers. Getting the certification before importing to Japan avoids delays or loss of shipments. You may not sell or distribute any of your products in Japan without the proper certifications. This concludes our webinar on Japan's market access, certification, and approvals for electrical equipment and wireless products. I hope the webinar was helpful for you in understanding the process for MIC approval and certifications, as well as what requirements are applicable. Compliance with the technical requirement of MIC is required for all radio and telecom products. All electrical equipment and devices require approval and testing in Japan prior to distribution or placement on the market. Vista Compliance Labs specializes in certifications, approvals, and compliance testing for electrical and radio frequency devices and is a 17025 accredited EMC RF compliance test lab and 17065 accredited product certification body. We are a telecommunication certification body in the US, Canada, EU, UK, Hong Kong, Singapore, and Japan, and we provide certification and approvals for all product types in countries all over the world. If you would like to stay in touch with regulatory updates, follow us online, and if you have any questions, comments, or suggestions on the information presented today or any general inquiries, you can reach us anytime at info@vista-compliance.com. Thank you for your time and have a wonderful day.